101. IP address is 192.168.3.1.255.255.255.0, and then no shutdown interface facet and 00. IP address is 10.0.0.6.255.255.255.252, and then no shutdown. That's it. Now we need to enable the one type of routing protocol. For example, OSPF. We can use the OSPF in router 1, router OSPF 1, router ID is quad 1. Then we need to use the network command 192.168.1.1 quad 0. Assume that all of these interfaces are working on area 0, and then a network 10.0.0.1 quad 0, again area quad 0, and after that network 10.0.0.5 quad 0 area 0. Until now we have enabled the OSPF on all of the interface of the router 1. Show IP OSPF interface can or interface brief, okay, can show us that we have OSPF on all of these interfaces, facet and 002 and facet and 003. Now let me to enable the OSPF on the router 2, router OSPF 1, router ID is the, for example, quad 2, then the first network statement 10.0.0.2 quad 0 area, again quad 0, okay, and after that network 192.168.2.2 quad 0 area, for example 0.0.0. And because now we have one direct link between the router 2 and router 1, we expect to see the OSPF neighborship between them. Show IP OSPF neighbor. Now it is working. This is residing on the DR other. You know that because this is Ethernet, now we should wait for finding or selecting the DR and BDR. After that they can be established the neighborship with each other. First let me to configure the router 3, router OSPF for example 1, router ID quad 3, and then the network is 192.168.3.1 quad 0 area 0, okay, and then network for example 10.0.0.6 quad 0 area 0 or area quad 0. Both of them are same. Now let me check the router 2. Yes, now we have neighborship between router 2 and router 1, and after some second between router 1 and router 3. If you check the router 1 routing table, show IP route can show us that, or show IP route OSPF can show us that we have learned 192.168.3.0 from the router 3, okay, and now. And also let me check the router 2's configuration. In router 2, show IP OSPF interface brief can show us that we have enabled the OSPF on the facet and 00 only. Why? Show IP interface brief, it can show us that the IP address of the facet and 01 is correct, but the OSPF configuration in the in this router OSPF 1, yes, we should change it to the 192.168.2.1. Look at here, conf t, okay, router OSPF 1, no network 192.168.2.2 quad 0 area, or for example quad 0, we should change it to the network 192.168.2.1, then quad 0 area 0. And now in the router 1 we can check again the routing table. After some second we will receive the 192.168.2.0/24. as you can see now we are receiving the 192.168.2.0 on one interface facet and 002, and the 192.168.3.0/24 on another interface. Actually this is like that we have two physical link to the for example two site, but you know that actually we have in reality we have only one physical link and two EVC or Ethernet virtual connection. This is the result of routing in the E-lines. When you are configuring the E-lines, after that you will learn the for example routes over some sub interfaces. Okay, now let me to show you the result of the configuration and how we can configure the E-LAN about the routing, not the E-LAN itself, because the configuration of E-LAN itself is beyond the scope of the CCNA. Now let me to show you how we can configure the IP addressing and routing in the E-LAN services. This is the E-LAN services that was configured before, okay, and now we have direct connectivity between the router 1, router 2 and router 3. Let me to show you the configuration of this scenario about the routing. Again, we should start from the scratch. R1 interface fast Ethernet 01. The IP address is the 192.168.1.1. Okay, 255.255.255.0. Then no shutdown. Now about the interface fast Ethernet 00, we should assign the IP address to this interface. IP address is 10.0.0.1. 255.255.255.0. Actually, as you can see here, we have one range of IP address between the routers. Also about the router 2, let me to configure the router 2 interface fast Ethernet 01. IP address is 192.168.2.1, 255.255.255.0, and then no shutdown. Then interface fast Ethernet 00 IP address is the, or for example, 10.0.02.255.255.255.0, and then no shutdown. Finally, the router 3, okay, conf-t interface fast Ethernet 01. IP address is the 192.168.3.1, 255.255.255.0. No shutdown. Interface fast Ethernet 00. IP address is 10.0.03.255.255.255.0, and then no shutdown. As you saw, I configured all of the interfaces in this E-LAN with same range and without the configuration of the, for example, sub interface. Now let me to enable the routing protocol router OSPF 1. Okay, router ID is quad 1, then network of 192.168.1.1 quad 0 area quad 0. The first command. The second is network 10.0.0.1 quad 0 area, then quad 0. That's it. And then the router 2, in router 2, router OSPF 1, router ID is quad 2, then network 192.168.2.1 quad 0 area, again quad 0. After that, network 10.0.0.2 quad 0 area, or for example quad 0. That's it. And then about the router 3, here router OSPF 1, router ID is quad 3, network, or for example 192.168.3.1 quad 0 area, then quad 0 again, okay, quad 0, and then network 10.0.0.3 quad 0 area, again quad 0. That's it. This is the configuration of the OSPF. Now let me to verify the result. We expect to have two neighborship, two OSPF neighborship between the router 1 and router 2 and router 3. You know that here now we should select the DR and BDR because this is a broadcast network. Show IP OSPF neighbor can show us that they are working to selecting the DR and BDR. After some second, the DR and BDR should be selected, and after that they can establish the neighborship. Look at here. We should wait again. Show IP OSPF interface fast Ethernet 00 can show us that now we are working on the selecting of DR and BDR. Yes, now the first neighborship was established with the router 3. Okay, let me to show you. Show IP OSPF neighbor. Yes, we have neighborship with the router 3. Router 3 is the DR because of its highest router ID, and the router 2 is the BDR because it has the second highest router ID, and the router 1 is the DR other. And because of that, in the show IP route of the router 1 now received from the OSPF, you can see that we are receiving 192.168.20/24 and 192.168.30/24 over one interface, not over two interface. This means that actually we have one link. You know that in the previous example in the E-line, we have learned these two routes from two sub interface. Okay, this is the difference between the E-line and also E-LAN. You will learn about the configuration of E-LAN and also E-line in future classes in the service provider courses. Now let me to give you a little more information about the access link that we have between the service provider and also the customer. In this picture, you can see the overall structure of the Metro Ethernet. As I explained before, here we have the POPs or point of presence located in the service provider, and you know that here we have the UNI or user network interface. This is the Ethernet access link. About the Ethernet access links, we have multiple type of fiber that we can use according to the technology that the provider supported. For example, we can use 100 base LX10. L means that we are using long wavelength, and 100 means the speed of this link, this fiber is 100 megabit per second, speed is 100 megabit per second, and the 10 means this, for example, a standard can support, this fiber can support up to 10 kilometer. Okay, and we can use 1000 base LX. Again, we